Here's a quick one. I want to voice over my notes for lecture 5, Trigonometry 1. And in this lecture, we are interested in looking at right-angled triangles. I want to see how to solve right-angled triangles. When we say solving right-angled triangles, we mean to calculate an unknown length or angle. So I hope and trust that you're going to enjoy this lesson. So kindly pay maximum attention as I run through the notes. So here is the objectives for the lesson. At the end of this lesson, learners should be able to 1. Apply the trigonometrical ratios, that is tangent, sine, and cosine, to solve right-angled triangles. 2. You should be able to combine trigonometrical ratios with Pythagoras theorem to solve right-angled triangles. 3. You should be able to derive the trigonometrical ratios of special angles. When we say special angles, we mean 45 degrees, 60 degrees, 30 degrees, and use them to solve related problems. Next, so here are some terminologies that you should acquaint yourself with for better understanding of this lesson. Excuse me. 1. Ratio. Ratio simply means the relationship between two similar quantities. Relationship between two similar quantities. We're going to be seeing the word trigonometry a lot in this topic, and it means the branch of mathematics that deals with the relationship between the sides and angles of triangles. Also, trigonometrical ratio. This is the relationship between the sides of a triangle with respect to a given interior angle. That is the combination of ratio and trigonometry. We give birth to trigonometrical ratios. So that's the relationship between the sides of triangle with respect to a given interior angle. Next, you're going to be seeing the word tangent of an angle. And what does it mean? It means the length of the side opposite the angle divided by the length of the adjacent side. Is to be written as tan theta. In short, tan theta. Alright, so that is if theta is the given angle. So it could be alpha, it could be phi, it could be beta, it could be A, it could be B. So this theta here is just a variable. Or in short, write it as tan of any given angle. Next, sine of an angle means the length of the side opposite the angle divided by the length of the hypotenuse side. So, and in short, we are going to be written as sine theta. Suppose again, theta is the given angle. Cosine of an angle is the length of the adjacent side divided by the length of the hypotenuse side, written as cos theta. So assuming theta is the unknown angle. Next, so here are some symbols that you see frequently as we progress in this lesson. This symbol means angle. This means parallel to. This symbol means perpendicular to. Right? When you write AB, 2 letters throughout this lesson, it means any straight line through points A and B. AB bar AB, a bar over AB simply means the straight line segment between points A and B. The absolute value of AB in this lesson means the length of line segment AB. Why this simply means the triangle ABC, and we see these symbols alpha, beta, beta, gamma, theta, phi, and delta. These all are Greek letters that will be used to represent unknown angles throughout this lesson. When we write this angle B or angle ABC or angle at ABC, all the mean angle at B. So here are the names of each of the symbols earlier mentioned. So this is alpha. Please get used to these letters because we'll be using them frequently in this lesson. So here is beta, here is gamma, here is theta, here is phi, and here is delta. All right. Next, we shall be looking at some student activity 1. So here is the student activity for this lesson. Given the figure, write the trigonometrical ratios using the letters indicated. All right, so here is a right angle triangle with vertices A, B, and C, and the corresponding length opposite each of the vertices are given as letter A. Small a is the side opposite vertex A, capital A. Letter B, small b is the side opposite vertex capital B. And letter C is the one opposite vertex capital C. So you're expected to pause this video and attempt this activity before you continue with the video. All right. So here is the solution to the student's activity. Now, to write the trigonometrical ratio of the indicated angles or letters using the indicated letters, we have to recall these acronyms. SOHCAHTOA. SOHCAHTOA is a word that represents, is an acronym that represents these 3 trigonometrical ratios. The S, the very first S here stands for, the S here stands for sine, represents sine, this S. And O represents opposites, and YH represents hypotenuse. So when you pick the first letter S, it forms this ratio, sine theta equals opposite over hypotenuse. All right, sine theta equals O stands for opposite and H stands for hypotenuse. That's the first quarter of, 1/3 of the acronyms. Because we divide it into 3 parts. So this is 1/3 of the acronyms. The first 3 letters SOH represent sine theta equals opposite over hypotenuse. Next, we have cos theta. Next ratio equals A represents adjacent and H represents hypotenuse. Cos theta equals adjacent over hypotenuse. Then finally, the third one, T represents tan theta and O represents opposite, while A represents adjacent. So it means tan theta is equal to opposite over adjacent. Now, this acronyms is very important as far as this lesson is concerned. You shall be applying it again and again and again and again. So endeavor to store it in your hard disk, in your that is inside your brain. Store it there and never you forget it again. All right, so I'm going to use acronyms to solve to attempt the student activity right now. Now, looking at when theta is A, when theta or if theta is A, this particular angle A, suppose here is our given theta. In the right angle triangle, there are 3 sides. The 3 sides of the right angle triangle is labeled. Okay, it's labeled, it's given names, but they are given names. The longest side is always the hypotenuse, no matter how the triangle is drawn. Irrespective of how it is drawn, the longest is the hypotenuse. The side facing the given angle, like in this case, the side facing the given angle is side BC, which is A, small a, facing that side is always known as the opposite side. The side facing the given angle, in this case, here is the given angle. all right, is known as what? The opposite, while the other side is the adjacent. Okay, I'll come again. The longest side of any right angle triangle is always known as the hypotenuse. The side facing the given angle is the opposite, always, while the other side is the adjacent. Now, suppose this particular angle theta at vertex A is the given angle. The opposite will be A, small a small letter A. But if the given angle changes to be at C, vertex C, the opposite will be small c, that is side AB, which is small c. Is that taken? I hope you are following. All right, having said that, we can now solve. So, if the given angle is A, if theta is at vertex A, sine A, remember, sine theta is opposite over hypotenuse. The opposite will be A, small letter A, while the hypotenuse is what? B. So that is sine A, capital A, is equal to A over B. All right? Cos A, remember, A, small a is the opposite, that is, small c would be the adjacent. Remember, cos theta is adjacent over hypotenuse. So cos A is equal to C over B. While tan A, which is opposite over adjacent, the opposite is small a, the adjacent is C. That is A over C. Suppose A is the given angle. This particular vertex or this angle is the given angle. So here is going to be the correct ratios, trigonometrical ratios. All right. Next, for sine C, cos C, and tan C. And if this particular vertex is where the angle is given, look at this part. Then the opposite and the adjacent will change, but the hypotenuse remain the same. So the opposite is now C, while the adjacent is A. Now, coming back to our trigonometrical ratios, sine theta opposite over hypotenuse. That means sine C will be opposite, which is C, small c, over hypotenuse, which is B. Okay? Now, cos C is equal to adjacent A over hypotenuse B, while tan C is equal to opposite C over adjacent A. All right, so is that taken? So that is the solution to the student's activity. Please look at it again carefully and make sure you understand it. Make sure you understand it because this is the beginning of the lesson. If you understand this 100%, I guarantee you, every other thing we shall be discussing this lesson will just be a walkover for you. This endeavor that you understand. Is that taken? All right, let's go back to the lesson. Now, next we have we're going to talk about the first what is it called again? We're talking about the first subtopic in this lesson, complementary angles. What do we mean by complementary angles? Definition. Two angles, theta and phi, are said to be complementary if they add up to 90 degrees. That is, if theta plus phi is equal to 90 degrees, then theta and phi are complementary. Here are some examples. The following examples of complementary angles. 1. If theta is 50 degrees and phi is 40 degrees, then theta and phi are said to be complementary. Why? Since their sum is equal to 90 degrees. When theta is 45, phi is 45, these two are complementary since they sum up to 90 degrees. When theta is 60 and phi is 30, when you add them up, you get 90 degrees. So that means they are complementary. 70 and 20 are complementary because their sum is 90. 65 and 25 are complementary because their sum is 90 degrees. So in summary, any two angles that sum up to 90 degrees are said to be complementary. All right, so let's look at these right angle triangles carefully. And My claim is that in any given right angle triangle, the two adjacent angles, are said to be complementary. That is, the angle theta at A and the angle 90, the angle at C, they are complementary. So that is why if the angle at A is given as theta, then the angle at C will be 90 degrees minus theta, because they are complementary for any given right angle triangle. Please take note of that. Any given right angle triangle. If the right angle triangle is a scaling one or an isosceles right angle triangle, the sum of the adjacent angle in that triangle are, or the adjacent angles are complementary. All right. Now let's look at this. Here, write the trigonometrical ratios of theta and 90 degrees minus theta using the letter above, the triangle lettered above. All right. So let's quickly do something here. Let's write it out and see how it looks like. I'm trying to select my pen. All right. So I've done that. So let's do some writing here. So sine theta, my theta is at A, it means the opposite is small letter A and the hypotenuse is B. Remember, sine theta is opposite over hypotenuse. So this is A over B. Cos theta is C over, that's adjacent over hypotenuse, C over B. Why sine 90 minus theta? So since 90 minus theta is now at vertex C, the opposite is now C. So opposite over hypotenuse is C over B. Then cos 90 minus theta is adjacent over hypotenuse, A over B. All right. Okay. So when you observe these ratios carefully, observe the ratios carefully, I believe you've noticed something. And what is that thing? Let's go to the next slide. Now notice from this above slide at slide 7, sine theta is equal to cos 90 minus theta, which is A over B. Let's go back to it. Can you see sine theta, A over B? Can you see cos 90 minus theta, A over B? So it means these two ratios are equal. And cos theta is equal to sine 90 minus theta, which is C over B. Let's look at it. So you can see cos theta, which is C over B, that is equal to sine 90 minus theta, which is also C over B. All right, so these two equations are used to solving equations involving trigonometrical ratios. Please never you forget it. Take it down, write it down in your jotter on your notes. So, and don't forget. So sine theta is equal to cos 90 minus theta, while cos theta is equal to sine 90 degrees minus theta. Now applying these two, let's say, equations, we shall look at one or two examples. And here is my very first example, example 1 in this lesson. It says solve the equations cos theta equals sine 40 degrees to sine 5 equals cos 2 5. Now let's look at the solution quickly. All right. So here is the solution, or here are the solutions to the example. The first part, cos theta equals sine 40 degrees. Recall that sine theta is equal to cos 90 degrees minus theta. We've just seen that right now. And that means our theta is given as 40 degrees. So it now sine 40 degrees equals cos 90 minus 40 degrees. So which means sine 40 degrees is equal to cos 50 degrees. Now, since sine 40 degrees is equals cos 50 degrees, we do some substitution in the given equation. Wherever we see sine 40 degrees, we replace it with cos 50 degrees. So by doing that substitution, we have cos theta equals cos 50 degrees. And of course, since cos theta is 50 degrees, meaning that to compare the value at the front of cos, means they will be equal. At least we can say cos will factor out cos. So it means therefore theta is 50 degrees. All right, so I hope that example was clear enough. So can I continue? All right, let's continue. So number 2, sine phi equals cos 2 phi. And we'll also do the substitution since cos 2 phi is equal to sine 90 minus 2 phi. We substitute cos 2 phi, or substitute sine 90 minus 2 phi for cos 2 phi. That is sine phi equals sine 90 minus 2 phi. Remember the rule we've just derived. So that is why the substitution is possible. All right, and sine is common to both sides. You can factor it out, leaving out phi equals 90 minus 2 phi. That is collecting like terms. This 2 phi will come over to the left. So phi plus phi is equal to phi plus 2 phi equals 90 degrees. That is 3 phi equals 90 degrees. Dividing both sides by 3, we give phi equals 90 degrees over 3, which implies that phi is 30 degrees. All right, very simple. I hope you understand the solutions to this example. Now we shall continue with the notes. Next, look at example 2. It says the ratio of the sides of an isosceles triangle is 6:7:7. Sorry, excuse me, 7:6:7. Find the base angle to the nearest degree. So this is a wire question. And example 3 also is this: calculate the magnitude of line segment PR and that of line segment RS in the figure below. Give your answers to 3 significant figures. So here's the figure. Now quickly show you the solutions to those examples as we continue with the lesson. So now here is the solution to example 2. Now I start by stating or representing the length of the sides to be x. Now since the ratio is given as 7:6:7, it means if the length is x, this will be 7 times x. Length AB, 7 times x. Length AC will be 7 times x, while length BC will be 6x. Okay, introducing the height of the triangle, which is a straight line from the apex of the triangle to the base. That line will definitely bisect the triangle into 2 equal parts, and therefore dividing the baseline into also 2 equal parts. So since length BC is 6x, it means length BN will be 3x, while NBNC will also be 3x. Now looking at one part of the triangle, that is in triangle ABN, I can actually deploy the trigonometrical ratio cos in solving for the unknown angle theta. Now remember, cos theta is equal to adjacent over hypotenuse. And in this case, the adjacent is 3x while hypotenuse is 7x. So we have cos theta equals 3x over 7x. Since x is common to both numbers, we factor it out. So we're having and dividing 3 by 7 gives 0.4286. Therefore, cos theta is equal to 0.4286. while theta is equal to the cos inverse of 0.4286. And the cos inverse of 0.4286 to the nearest degree is 65 degrees. So say hence, the base angle to the nearest degree is 65 degrees. Very simple. And next we have example 3 solution at the right side of the screen. So it says calculate A length PR. So let's look at from triangle PQR, Okay, the x there is the opposite side because it's the side facing the given angle, while 6 is the adjacent. So since opposite adjacent are the two things involved in this particular case, it means we shall deploy tan theta. Remember that tan theta is equal to opposite over adjacent. So we have tan 50 degrees where theta is 50. Tan 50 degrees is equal to opposite x over 6 centimeters. Guess what happened here? What will happen or what happens to get the next line? All right, that is very, very good. So we made this tan 50 over 1 and cross multiplied. So tan 50 over 1, then cross multiply. 1 times x is x, while 6 times tan 50 is 6 tan 50. Please do not make the mistake. Do not do the mistake. Some students, over my years of my teaching experience, I've seen some students multiplying a number to another number that is at the front of trigonometrical ratios, like in this case. So some students will multiply 6 by 50, all right, and the answer will turn to tan 300, which is very wrong. Please don't do that. For any trigonometrical ratio, when you're multiplying, the number should always go behind the trig ratio. You find the values, calculate or look up the value from the table or your calculator of that trig ratio before you multiply it to the whole number. It is wrong to multiply 6 by 50 and say tan 300. That is wrong, very, very wrong. It is exactly what you should do. Like x equals 6 tan 50. And tan 50 is 1.1918 to 4 decimal places. So our x is equal to 6 times 1.1918, which is equals 7.1505. And approximately to 3 significant figures, our length PR is 7.15 meters or centimeters. All right. Now, next we have tan, okay, solve for length PRS. Length RS in this case, my y is, here we have y as the opposite, and x here in this case should be the hypotenuse. All right, so that's an error here. Let me quickly rectify the error. All right, so when you look at triangle PRS carefully, you will discover that length side PR is the hypotenuse, that is the longest side of the triangle, while side PRS is the opposite, the side facing the given angle, and finally side PS is the adjacent. Okay, since the right angle is at S, please note that the hypotenuse side is always that side facing the right angle of the given triangle. So the right angle is at S, therefore is the hypotenuse side. So in that case, the trigonometrical ratio that is suitable to solve for the unknown y is sine. So we have sine 28 degrees equals opposite, which is y, over hypotenuse x. All right, so we have, therefore, when you make this over 1 and cross multiply, so y times 1 is y equals x times sine 28 is x sine 28. And that is y equals 7.15, since we solve for our x at 7.15 centimeters, times 0.4695. That is the value of sine 28 degrees. So when you take the product of both numbers, you get 3.3567. Therefore, the magnitude of RS, the length of side RS is equal to 3.36 centimeters to 3 significant figures. Okay, let's see what we have next in the notes. All right, so here are some exercises for you to attempt. Number 1 and number 2. Please do this, attempt these exercises and submit it as soon as you can. Then let's look at some more examples before I end this lecture. So this lesson. So you have examples 4 and 5. I think I've also solved these problems. Let's look at it quickly. Example 4. Here's example 4. A ladder of length 6.0 meter rests with its foot on a horizontal ground and leans against the vertical wall. The inclination of the ladder to the horizontal is 80 degrees. Find correct to one decimal place. A. The distance of the foot of the ladder from the wall. B. The height above the ground at which the upper end of the ladder touches the wall. So here is just a sketch of the problem. So suppose this side, this straight vertical line represents the wall, while the inclined line represents the ladder. So here is the distance from the vertical wall to the foot of the ladder D, while the height of the vertical wall is represented as H. So we are given the length of the ladder as 6.0 meters, while the inclined angle is 80 degrees. So this is the sketch of how the question should look like. The first part says calculate the distance of the foot of the ladder from the wall. So that is D. And D in this case is the adjacent side of the right angle triangle formed when the ladder inclines the vertical wall. So D is adjacent, while the ladder itself is the hypotenuse of the right angle triangle. All right, so since we have the adjacent and the hypotenuse, it means the suitable trigonometrical ratio that solve this problem is cos. So we have cos 80 degrees since cos is adjacent over hypotenuse. So that is cos 80 degrees equals d over 6. D, the distance, over 6, the hypotenuse. Right, so d is equal to 6 cos 80 degrees. Cos 80 degrees is 0.1736 in degrees. Then multiply by 6, and that would be 1.0419. So therefore, the distance of the foot of the ladder from the wall is 1.0 meters to the nearest one decimal place. B. To solve for the height of the ladder, of course, the height is the opposite side of the right of the triangle, while 6 is still the hypotenuse. So in this case, sine theta, or the trigonometry ratio sine, would be suitable to solving this problem. So we have sine 80 degrees equals opposite h over hypotenuse 6. Cross multiply, you have h equals 6 sine 80 degrees. That is h equals 6 times 0.9848. H equals 5.9088. Therefore, the height of the vertical wall is 5.9 meters to one decimal place. So you see that the solution to this example is very simple. And finally, we have example 5. So a point T on the same horizontal level as the foot of a tower. If the distance of T from the foot of the tower is 80 meters and the height of the tower is 60 meters, find the angle of depression of T from the top of the tower. Give your answer to the nearest degree. So here's a sketch of the problem. Now this vertical line here represents the tower, while this is point T, which is on the same horizontal ground level as the foot of the tower. Now here is the angle of depression. There is someone in the tower there looking at point T. The angle formed between the person's, the line that connects the person's eye to point T with the horizontal plane is the angle of depression. So that is what I have represented as phi. But we know that the angle of depression is always equal to the angle of elevation. Why? Because the two angles are alternate. So since this angle is alternate to this, therefore the angle of depression is equal to the angle of elevation. So if I go ahead and solve for the angle of elevation, indirectly I've solved for the angle of depression. Does that make any sense? All right, now we're given the distance from the foot of the tower to point T as 80 meters, while the height of the tower itself is 60 meters. Now, since the height of the tower is the opposite, because it will face face the given angle, the phi, while the other side is the adjacent. Opposite, adjacent. Which trig ratio will be suitable to solve this problem? Correct, tan. So we to apply, we say tan phi equals opposite over adjacent, 60 over 80. This tan phi is 0.75. For phi is equal to the tan inverse of 0.75, and that will be equal to 36.8699. Therefore, the angle of depression of T from the top of the tower is 37 degrees to the nearest degrees. Now, these solutions and examples and explanations, I want to believe that is straightforward and you've been able, or you all have been able to explain the topic to my very best. So please endeavor to see this video carefully, watch it again and again until you get a full understanding of the concepts explained. All right. So for further practice, I would encourage you to do this assignment from your textbook, New General Mathematics for SS1, page 135, exercise 11A, number 7, 17, and 27. Upload in the post I will create for this part. Submit your assignment appropriately and as at when due. So hope to see you in the next class. Thank you for paying maximum attention and for watching the video. Keep studying and remember to always stay safe. As you do that, I believe God will continue to bless you. Have a nice time.